Okay, Unit 2 motion, video 2, here it is. I'm going to apologize right now. I'm going to try and talk loud. I have not bought the new microphone yet, so it's still going to be a little quiet, but I'll work on it. Today we're going to be talking about vectors. What is a vector? Speed versus velocity, what's the difference? Acceleration, and then I'll show you a little bit about the acceleration triangle. So I think most of you are familiar with the concept of a vector from Despicable Me. This guy his name was Vector, and he says, "I am committing crime with both direction and magnitude." Right? So that's totally the definition of vector right there. So, but what does direction and magnitude? What's that really mean? Okay, so really a vector is like a giant arrow. Okay, you can think about it as a giant arrow. And an arrow points in a certain direction, right? So that's the direction part of what he's saying. And then it also has a certain value or magnitude. So magnitude is just a fancy way of saying amount or value, okay? And so I'm going to give you some examples of vectors. Here, right now below us, this could be a vector for something that's traveling at 10 meters per second. Say a cat is running at 10 meters per second, and they're running to the right. Okay, you see this? Running to the right. So this arrow is a vector, and it shows us the direction and the size. Okay, so here's another example. Okay, oh, typo. So now we have a vector that has a value of 15 meters per second, and you notice that it's bigger, right? So the arrow shows you, right, the magnitude or the value of in this case the velocity. Okay, so here's another example. All right, so now we have a vector with the value of negative 10 meters per second. It's pointing in the opposite direction. Okay, so this idea of a vector is it's simply like an arrow that physicists use to represent both a direction and a value, and it can be a velocity, it can be an acceleration, it can be a couple of different things, but for us we're going to use it mostly with velocity. Okay, so speed versus velocity. Some of you have talked about this, some of you have had these ideas already, but the difference between speed and velocity is that velocity is a vector. Speed is not. Okay, so velocity has direction. So if you're going backwards, if I walk backwards away from an origin with a velocity of 5 meters per second, it's going to be my velocity will be negative 5 meters per second, but the speed will still be 5 meters per second. So speed is just the magnitude, right, of how fast you're going, and velocity also has a direction. So think about like a speedometer in your car. If you drive in reverse in your car, it's not like there's negative numbers on the speedometer, right? It just goes to 0, and if you're going 10 kilometers per hour backwards, it just says 10 kilometers per hour. So a speedometer measures speed, right? Whereas velocity, if it were showing velocity, it would show like negative 10 kilometers per hour or something like that, okay? So yeah, we'll talk about that more in class. So now we kind of have to have a little bit of a new equation for velocity, right? So before we just had velocity equals position over time, and that's still true for speed, but a little bit more exact definition in an equation for velocity is velocity equals final position minus initial position divided by time. So for example, if I go from a position of 10 meters to a position of 2 meters in 4 seconds, then this is my velocity. All right, you've got your final position, which is 2 meters, to a position 2 meters, minus your initial position, which is 10 meters, right? And you divide that by 4 seconds, you get negative 8 meters. Divided by 4, negative 2 meters per second is my velocity, okay, because it's a vector, it has direction, right? Our speed, 2 meters per second. All right, so the way you go between speed and velocity is speed is just the same number, just always positive. Okay? All right, acceleration. So here's a good example of this dad is like, I'm gonna accelerate really fast, right? He just like he just puts his foot right on the gas pedal, right? And you can see it's like all the stuff is flying all over the place. The kids are screaming. The phone and the banana is flying everywhere, right? This is This is an example of acceleration. And the way that we define acceleration is like this. Acceleration is simply a change in velocity. So whenever you change velocity, whenever you change speeds, there's acceleration, right? So yeah, you go from 0 meters per second to 10 meters per second in 2 seconds. You're accelerating, right? If there's a dog in the road and you slam on your brakes and you go from 60 kilometers per hour to 0 kilometers per hour, you're accelerating, right? You're decelerating, right? You're accelerating. You're changing your velocity. And once again, we have a triangle to calculate velocities, or acceleration, sorry. So this is our acceleration triangle. And it's almost the exact same as velocity, except now we have acceleration is equal to velocity divided by time. So how much your velocity changes in a certain amount of time. All right, that is your acceleration. So here's an example problem. I am driving in my car, right? In 5 seconds, I go from a velocity of 0 meters per second to a velocity of 30 meters per second. What is my acceleration? So here we go. Acceleration equals velocity divided by time. Acceleration equals 30 meters per second divided by 5 seconds. So that means that in 5 seconds, you change your velocity 30 meters per second. Your acceleration then is 6 meters per second squared, right? Because you've got seconds here and seconds here. So it becomes seconds squared, and that's important because that's what acceleration is. And like velocity, acceleration is also a vector. Okay, so I think that's it for everything for today. Acceleration, change in velocity, vector, right? A vector is something with direction and magnitude, okay, like our friend here. And yep, we'll talk about this on Tuesday, I believe. Have a nice day.